So we'll just do this example together, then I'll kind of explain where these numbers are coming from. So it says a political candidate has asked you to conduct a poll to determine what percentage of people support her. If the candidate only wants a 2% margin of error at a 90% confidence level, what size of sample is needed? Give your answer in whole numbers. So basically, for any problem involving sample size, you're going to use one of the formulas from the PowerPoint notes from Chapter 8 on Blackboard. This is the one taken from the notes for proportions. It's on slide number 64. Okay, so you can watch the YouTube videos and find the other formulas, or you can go through the PowerPoints. But we need 4 things. We need P hat. We need Q hat. We need our margin of error. And then we need the Z of alpha over 2. Okay, that's one variable. So P hat is the sample proportion. So you'll see here that it says, well, we don't have a sample proportion. Okay, sometimes it's given to you, sometimes it's not. So let's just say they said the sample proportion was, I don't know, 37%. They'd say this, 0.37. Well, then this would be 0.37. And Q hat would just be 1 minus this, so Q hat would be 0.63. They add up to 1. Okay, but since they don't give them to us, we can't do that. Whenever they don't give you P hat, you're always just going to assume that P hat and Q hat are both 50%, unless they tell you otherwise. Okay, our margin of error is 2%, written as a decimal is 0.02. Now, where do we get this Z value? Well, I'm going to draw the normal curve. Z scores are values along the standard normal curve. So there we go, like that. There's roughly a normal curve. Remember, standard normal means middle is 0, mu is 0, and the standard deviation is 1. So I'm looking for the value of Z. So here's Z. Here's negative Z. It doesn't matter which one you find because we're squaring it anyway. Okay, but I have a positive and negative Z that cut off the middle, 90%. Okay, or we'll change a different color, or the same thing as 0.90. So I need to find what this Z value is. So I'm going to use my calculator. I'm going to go to my distributions menu and hit inverse normal to find the value that cuts off that 90%. Now the first question it has is area. Now the calculator wants to know what's the area, and it doesn't say it because these calculators are kind of stupid, but it means area to the left. It always refers to area to the left. So if I'm looking at this Z value, it wants the area to the left of it. Well, if I'm cutting off the middle 90%, that means there's 10% left over. Okay, this curve is symmetrical. So there's 10% left over. That means 5% has to be here and 5% has to be here. Okay, so if I'm looking at this Z value, how much area is to the left of it? Well, it's this 90 and this 5 for a total of 0.95%. Or 0.95, sorry, 95% or 0.95. Mu is 0, sigma is 1. You get your answer. Let's say this is 1.645. I'm just going to round it for right now, 1.645. Just to show you if I want to find this Z value, you can do the same thing. Distribution's inverse normal. What's the area to the left of this guy? Well, that's just 0.05. 0.05. And I'll get the same thing but negative. See, that's why I have positive and negative Z. Okay, doesn't matter which one you use. If you want to use this one, I have students who use this one and just drop the negative. Doesn't matter. So now I have this formula here. The first thing I'm going to do is I'm going to take my Z value, which is this number here. I'm just going to go grab it. I'm going to square it. That's the next step is square it. Then multiply it by P hat and by Q hat. So I'll multiply it by 0.50 times 0.50. So that's my numerator. This whole numerator is that. So now it's going to be divided by this margin of error squared. I'm going to square the margin of error, 0.02 squared. Don't worry about what that means. Okay, we're just going to take the top, which is this number, and divide by that number. So I get 1690.96. So no matter what this decimal is, this will round up to 1691. But let's just say that this was 1690.21. Okay, this should normally round down to 1690, but you want to make sure you have a large enough sample size. If I round this down to 1690, it might not be large enough anymore. So for these particular problems with sample size, no matter what what decimal you get, always, always, always round up. So this is going to be 1691. And then all the different sample size questions behave the same way. It's just the formula is different. So that's really how they're done.